Very good morning, friends. We were dealing with the green chemical techniques. Many of the green chemical techniques concentrate on the saving of energy or effective utilization of the energy. One of the methods of effective utilization of energy is the microwave synthesis. This microwave synthesis, as we have seen, it increases the reaction rate enormously by accelerating the reaction process. It interacts directly with the molecules at the molecular level. Another approach in which the energy utilization is optimized is ultrasound organic assisted organic synthesis. It is also named as sonochemistry. There is an historical overview before going to this ultrawave assisted organic synthesis. Ultrasonics deals with ultrasound. The frequency range of ultrasound is from 20 to 10,000 kilohertz. All this ultrasound waves generation started with the Curie brothers by their invention of piezoelectricity. What is this piezoelectricity? Piezo is the German word which indicates pressure. Means when the pressure is given to the piezoelectric substances like quartz, ceramic, etc., that vibrations which is given by the pressure gives rise to electricity generation. Means it is the process of conversion of mechanical energy into electrical energy. Reverse was equally true when the piezoelectric material is kept and the voltage across the electricity, then it gives the vibrations, it compresses, and that produces the ultrasonic waves. With the utilization of this piezoelectricity, in the year 1893, Francis Galton invented Galton's whistle, which is also known as dog's whistle. With this Galton's whistle, he proved that the hearing range of animals and human beings are different. He could produce ultrasound waves to which the dogs and cats responded, but it was not in the hearing range of the human beings. In the year 1912, we know the Titanic tragedy, and this occurred because of the fact of collision with the iceberg. If at all this would have been predicted before it collides, then the tragedy would have been stopped. In the same year, Alexander Bell tried to develop an echo technique where he sent the ultrasound waves, and that ultrasound waves which hit the object will gives the echo sound back, and detecting the echo sound back, it gives the distance of this object and the size of the object and the direction of the object. But however, it was not very much successful. This was again continued in the year 1917. Paul Langevin created the technique in which they could measure the distance of icebergs and submarines, and also the size of submarines and icebergs and the direction of the same. This paved the way to avoid the accidents that used to occur before. The same ultrasound waves were utilized in the formation of various products. It was applied in chemistry for the synthesis of various products in the year 1945. With this historical view, let us know about these ultrasounds, how they are produced, what is the mechanism of heating by using ultrasound waves. Like we have seen dipolar polarization, interfacial polarization, and ionic conduction, and so on and so forth in microwave synthesis. Ultrasound waves is the waves which is beyond the human hearing. It has the frequency of about 20 kilohertz. The human hearing range is between 16 to 18 kilohertz. The conventional power ultrasound waves range lies between 20 to 100 kilohertz. The extended range for sonochemistry is 20 kilohertz to 2 megahertz. The ultrasound waves have been utilized for diagnostic purpose to get the image of the human beings, and its range lies between 5 megahertz to 10 megahertz. It is ultimately the interaction of ultrasound with the material, and it is felt that the animals hearing range will be above and below the human hearing range. The elephants can hear to the sound frequencies below 16 hertz also. It is the same case with the dolphins too. The dogs and cats can hear the ranges up to 40 to 65 or 70 kilohertz. Now, these ultrasound waves have been utilized for the purpose of reactions carrying out for the effective synthesis of the organic compounds. What is the mechanism of behind it? In case of ultrasound waves, when we pass through the liquid medium, these waves passes through by compression and refraction of the medium. The medium particle compresses and it relaxes, and during the process the waves get transferred. This compression and rarefaction gives the waves through which it passes. Here, the distance between the two troughs and the crust is called as the wavelength, and the depth of penetration is rarefaction, and this is called as amplitude. During this compression and rarefaction of the medium, there arises the bubble formation during the compression, and this bubble is filled with gases or vapors of solvents, and during the rarefaction it expands. Again compression, the new bubble is formed, and that combines with this bubble, and the bubbles grows on during compression and rarefaction, and the process continues until the bubble reaches the unstable size. When it reaches the unstable size, if you go for bubble radius in micrometers and the time, if it give the graph, the formation of bubble occurs and it goes on rising during the compression, and it goes to that extent at particular position it reaches the unstable size, and when it reaches the unstable size it explodes, And when this explodes, it creates this hot spot. And this hot spot has a temperature of around 5000 degree Kelvin and also has 2000 atmospheric pressure. This enormous energy and pressure which is released, it is converted in the form of heat. But this formation of bubbles is called as cavitation, and as it is not stable, it is called as transient cavitation. It is transient, temporary. Because of this transient cavitation, enormous energy released is also transient in very small period of time. But when n number of bubbles are collapsed at a time, energy is released, and that energy can be utilized for the reaction to occur. The formation of the acoustic bubble we have shown here, and the bubble size growing, and the cavitation dynamics we have shown in this figure, and this is transient cavitation. Here, when this transient cavitation occurs, it in the liquid medium, when it explodes, extreme condition, the higher temperature and pressure is released. At around 4000 to 5000 degree Kelvin, temperatures are released, which is also transient in nature. And another phenomenon can also occur in solid liquid system. When the bubble collapse, the liquid enters through the bubble when it collapses as at a jet speed, and that jet speed liquid, when hits the solid material, it erodes the surface of the solid material, and it helps in the cleaning, that is called as surface cleaning. Ultrawave sounds are used for surface cleaning, and it may causes destruction of the boundary layer, or it may cause surface activation in case of catalysts, and there will be an improved mass and heat transfer. In solid liquid system, it gives this effect. In liquid system, it gives the enormous release of the energy. In the large particles, if it is there, when there is the defects, and into these defects the solvent enters into it, and it breaks the molecule, and when it breaks, it gives the smaller particles, and the smaller particles which are formed, this leads to a process called as surface erosion. The smaller particles can again combine, and it gives to fusion also. That's why this dynamics has been utilized for many purpose. In case of liquids which are too immiscible, there is a layer between this, and this disruption of the phase boundary occurs, and it helps in catalyst to transfer across the phase, and it is helpful in increasing the activity of the phase transfer catalyst. The ultrasonic has an effect, or it will not have an effect. If it do not have an effect in the system, then we have to go for another alternate approach for heating. If it is having an effect, then the effect is temperature dependence of the energy of activation of different reactions are significantly different, and this difference changes its selectivity. Thus, it can be helpful in effective mixing, it is effective cavitation, and also helps in surface cleaning. Overall, there is various parameters which affects the process. Increasing in the frequency of this acoustic pressure, it increases the energy. And as the energy is increased, the reaction rate also increases theoretically. But however, in practicality, optimum frequency is taken as we have to balance the reactivity and selectivity. If reactivity is very high, selectivity is less. To enhance selectivity, the reactivity should be optimized. In turn, the acoustic frequency can be optimized to achieve this reactivity and also selectivity. The effect is different in every reaction. That's why general rule cannot be made. Depending upon the reaction, what we need, we have to optimize the frequency of ultrasound waves, what we have to use. Similarly, the acoustic power, higher the energy, higher the reaction rate. But however, it also affect the reactivity and selectivity. Thus, it should be also optimized in the similar fashion as that of acoustic frequency. The temperature helps in the formation of cavitation bubbles. In general, lower temperature is better. But again, optimization is required as the higher temperature increases the probability of cavitation. External static pressure also another parameter which plays a role. However, it is not very much clear. In general, bit higher pressure has a better effect. It is used in the process of ultrafiltration. The gas help that a polytropic ratio gives to or aids for thermal conductivity and solubility. However, inert gas is the most preferable gas as it should not affect the reaction. Solvent, as far as possible, it should be inert to ultrasound waves. Usually, higher boiling points solvents are preferred, but however, there is a controversy where diethyl ether, a low boiling liquid or organic liquid or solvent, has many applications in ultrawave sonication chemistry. Here, various experimental parameters like acoustic frequency, acoustic power, temperature, static pressure, gas, and solvent, its physical parameters which it affects, and the effect which it brings has been summarized. By optimizing all these experimental parameters, we can effectively utilize the ultrasonification for the better completion of the reaction. However, unlike microwave synthesis, there is where there is a direct interaction of the microwaves with the molecules. Here, in ultrasonication, the ultrasonic waves do not interact with the molecules of the reaction material. It only interacts with the medium, which helps in formation of transient cavitation. The implosion of this cavitation releases enormous energy and pressure, which is also transient and which is helps in carrying out the reaction. How it is effectively utilized, what are its applications, will be the subject of discussion in the coming presentation. Till then, have a nice day. Thank you.